question is find the angle at the center of the circle when the perimeter of the sector is equal to the arc length of the semicircle. They have asked us to find out the value of the central angle of the circle, that is theta. We have to find out the value of theta, and they have given us the condition that the perimeter of the sector. So let P be the perimeter of the sector, and they have given here that perimeter of the sector is equal to the arc length of the semicircle. So perimeter of the sector is equal to arc length. So let S be the arc length, and arc length of a semicircle be S subscript SC. Let us first visualize this. We have a standard formula for finding out a perimeter of any given sector. That is, for all perimeter of a given sector is equal to 2R plus S. And then next they have given us this perimeter is equal to the arc length of the semicircle. Let this be our circle, and let us divide this circle into half. Let this portion be our semicircle. Arc length of the semicircle is nothing but this portion, arc length of the semicircle. This can be found out easily by finding out the circumference of this entire circle and dividing it by 2. That is, we will be dividing it by 2 to find out the length of the arc of this portion of the circle. For all, a standard formula to find out the circumference of a circle is, let C be the circumference of the circle. C is equal to 2 pi r. We have to find out the circumference of the semicircle, that is C subscript SC, where SC is the semicircle. So that will be equal to half the value of circumference of the entire circle, which is equal to half into 2 pi r. So 2 and 2 cancel out each other. So we are left with pi r. This value here, that is the circumference of the semicircle, is equal to the arc length of the semicircle, which is equal to pi r. Let us equate these two terms, that is arc length of the semicircle and the formula for finding out the perimeter of a given sector. Perimeter of the sector is equal to arc length of the semicircle. So which will be equal to 2r plus s, which is here. This will be equal to pi r. Now when we look into this equation, we have a formula for this term, that is the arc length. For all, arc length of a sector is equal to r theta, where theta here is always in radians. So next let us substitute this formula in the previously obtained equation. 2r plus s, that is r theta, which is equal to pi r. In the question they have asked us to find out the value of theta. So let us group the terms accordingly. So first let us keep our term which is having theta in the left hand side and move all other terms to right hand side. That is r theta is equal to pi r, and we are taking this term, that is 2r, to right hand side. So it will become minus 2r. Let us take out the common term here in the right hand side, that is r and r. So r theta is equal to r into pi minus 2. So r and r will cancel out. So now we have the value of theta, that is theta is equal to pi minus 2 radians. Radians because here in this formula the value of theta here is in radians. So we have found out the value of central angle of the circle. This will be our final answer, where the value of theta is equal to pi minus 2 radians. If you understood the concept, subscribe to the channel and like the video. Thank you.